This video lesson is going to be about how changes in the slope and the y-intercept affect the graph of a linear function. You should have already at this point completed the vocabulary section of your notes. You just need to fill in the words from that word bank in that vocabulary section. If you have not completed that, stop the video right now and complete that. If you have completed it, you should be looking at the other side of that, which has these problems on there, and it also has some questions that you need to answer as we go. We're going to just work through 4 problems, and that's going to be the lesson. We're going to teach you how to work it by working problems that are similar to what you're going to see on the end of course exam. The first problem that I'm going to work is problem number 1 right here. And we're starting with the equation f of x equals 5x plus 10. So we know from y equals mx plus b that that means that our slope is 5 and our y-intercept is 10. Okay, we're going to change that equation, and we're going to change it to where the y-intercept is changed to -5. So we're going to write a new equation, and we're going to change the y-intercept to -5. So that's 2 -5 is an important thing to notice here, because what we're doing is the old y-intercept is going to completely go away, and it's going to be replaced with -5 because we're changing it to -5. So our new equation will be y equals 5x minus 5. Because our slope does not change, remember that this is our slope, that stays the same. The only thing that's going to change is the y-intercept. So our y-intercept changed from 10 to -5. Okay, so that's how the equations change. How did the graph change? The way we need to do that is we need to graph these 2 lines on a graph. They gave us the graph right here. Let's take advantage of that. So we're going to start at our y-intercept of 10, go up 5 and over 1. That's the same thing as going down 5 and over 1. And you don't need to worry about getting this just perfect, because this is a multiple choice problem. We just need to get it close enough so that we can tell what's going on. So this is the graph of this equation right here. Y equals 5x plus 10. That's the starting equation. It says we're going to take this equation and then we're going to change it. So this is the one we're starting with. And then we're going to graph the new equation. We're going to graph y equals 5x minus 5. So that means we're starting at -5, our y-intercept. And again, we're going to go up 5 and over 1. But up 5 and over 1 is the same for the 2 equations, because they have the same slope. Okay, now that I have them graphed, it's easy for me to evaluate my answer choices. F says the x-coordinate of the x-intercept increases. Yeah, it seems like it's about -4 when we start, and it goes to about a +1. That does seem to be an increase. Let's look at the other ones and see if they are possible. The y-coordinate of the y-intercept increases. No, it went from 10 to -5, so that's a decrease. That's not the right one. The new line passes through the origin. No, it comes close, but it doesn't quite pass through the origin. The slope increases. No, the slope stayed the same. So our answer is F. Okay, let's work the other problem. I'm going to erase this before we start. Okay, so if we look at this problem right here, now we're starting with this equation, y equals 3.25x minus 18.75. Okay, this time we're going to increase the y-intercept by 32.5. That's different than increasing it to something. Increasing it by something means we're going to add 32.5 to it. So our new equation will be y equals 3.25x plus 13.75. So now these are the 2 equations that I'm working with. That's my original equation, and then this is going to be my new equation. I still want to graph them. But this time let's try graphing them on our calculator. So we're just going to go to the calculator and we're going to put these 2 equations in. So I'm going to enter y equals 3.25x minus 18.75 and y equals 3.25x plus 13.75. I need to remember which one I entered first. The one that is on the top right here is my original equation. This is my new equation. So when I graph them, I need to pay attention to which one is which. Okay, when I do graph them, I'm going to see that they make parallel lines. And I can see some things about the x and y intercepts. And so now I'm going to go back to my problem to try to determine what the answer is. Okay, my first answer choice does sound correct. The new line is parallel to the original. Yes, that did look parallel. Okay, if I look at the other one, the x-coordinate of the x-intercept increases. That's going to not be true. That's going to not be true because my x-intercept of my original equation right there, there's my x-intercept of my new equation. No, it actually decreased. Okay, so that one I know is not true. The y-intercept, the y-coordinate of the y-intercept decreases. No, I can even tell from my equations that it increased. The new line has a steeper slope. Again, I can tell even from my equations that the slope is going to stay the same. So I know the answer is A.
Okay, we'll now try to look at two different types of problems, and the two problems we're going to be looking at are going to be focusing on the effects of changing the slope in the y-intercept. What happens when we change slope and y-intercept? What type of impact does it have on the type of problem we're working on as it applies to real-life situation? Here we have a problem on number 1 that says appliance repairman is charging money based on a function that says T is equal to 50H plus 35. 50 being his hourly rate and 35 being the y-intercept, the beginning point, which in this case happens to be $35, sort of flat fee before he even gets to start working on it. And the repairman decided to go ahead and change the way he charged money, and he came up with a second function that says 50H plus 45. Something in this case changed, namely the beginning amount, the flat fee he's charging. You can see that the slope in both cases stayed the same. The only difference between the two functions is that the beginning point, the y-intercept, is different. It went up from 35 to 45. But if you focus on the question itself, it says, what will be the effect of this change on the amount that he charged for each job? That means it's referring to the total amount. In order for us to be able to do a quick comparison between the two, we could create mini tables real quick and see what happens. The number of hours compared to the first function and the second function. In the first function, we know that the function he's using is 50H plus 35. For the second one, it is 50 times the number of hours plus 45. So just to go ahead and get a quick look at what this turns out to be in terms of the difference, we can go ahead and plug in 0 hours worked, 1 hour worked, and 2 hours worked, and plug these inside the functions to find out the total amount he's charging. The total amount in the case of the first one is 50 times H plus 35, which turns out to be 50 times 0 plus 35, which is just $35. Whereas in the second case, it would be T total amount charge equals 50 times 0 hours plus 45, which turns out to be $45. Already we can see that even from the first row that the total amount he's charging is different when we compare the first function to the second function. Okay, we can try one more and see what happens. The total amount he charged for the first hour, 50 times 1 plus 35, which in this case turns out to be $85 if he just worked the first hour. And for the second one, the second function, it would turn out to be 50 times 2 plus 45, which in this case would be 50 times 1, I'm sorry, 1 hour is being worked. 50 times 1 plus 45, that would be $95. So you can see quickly that the rate, the amount he charged, the total amount he charged keeps changing from 35 to 45. That's an increase of $10. And it goes also from 85 to 95, which is also again an increase of $10. This tells us that the total amount that he charged for each job increased by 10. This would be the answer choice that we go with. And it did not decrease, as you saw from the table, by $10. And the amount he's charging per hour, that is our rate per hour. That did not change in both cases. It was $50 per hour. Therefore, we say that choice C and D would not work either. So that way, we can conclude that choice A works for this problem. Okay. In our second problem, as it applies to a real-life situation, we've got an electrician charging a flat fee. I would underline that word right there. Flat fee of $900 to wire a barn, and an additional $35 per outlet installed. That per outlet installed tells me that it is referring to a rate as in the slope of the line we're discussing. So if I wanted to write my equation y equals mx plus b for this first scenario, the electrician would charge a flat amount of $900 with $35 per hour, which in this case turns out to be the slope. And that's the first situation. And he decided the flat fee needed to be changed from $900 to $1,200. That would change our equation, second equation, to y equals mx plus b again, which in this case would be y equals 35x plus $1,200. You can see that in both cases, the slope, the rate at which he's charging per installation is still the same, 35, whereas the difference comes out in the beginning point, the flat fee, the starting fee, which went from $900 to $1,200. So if we look at our choices trying to answer which one of these characteristics of the graph would change, we can see that the slope would increase, does not work because the slope stayed the same. The y-intercept would increase. Yes, the y-intercept did indeed increase from 900 to 1,200. That's a plausible answer choice to take into consideration. And you look at the rest of them, you would see that the slope and y-intercept would decrease. Slope stayed the same, and the y-intercept did not decrease. That did not make any sense. And the graph would not change. Definitely the graph would change in this case because the beginning point is different. So we would go ahead and pick answer choice which says the y-intercept would increase and not any of the other choices.